So this week, we're simplifying roots. So we start off with a little bit of vocabulary, which isn't super exciting, and then we'll get to the actual math. So anytime you're dealing with a root, you have three separate parts. The index, that's the root you're taking. So if you don't see a number there, that's a square root, so the index is 2. Otherwise, it will be listed like our first example here is the fifth root, so the index would be 5. And then the third, the cube root, so our index would be 3 for our second example. The actual sign itself, the funky looking division sign, that's our radical sign, or just radical. And then the number underneath the sign, it's your $1,000 vocabulary word, the radicand, which is similar to the name of the number inside your division house, if you remember that far back. All right, so if you need to talk about these three things, there's some vocabulary words for it. The second part we talk about is the principal root, and this just makes our work a little bit easier. Like if we say the square root of 25, that can either be positive 5 or negative 5, right? When we talk about principal root and we have an even index, like all of these is the square root second power, so that's an even index. We're going to say, if it's just the root listed, we're only going to give the principal root as our answer, which is just the positive version. So we would say square root of 25 is just 5. Okay. Now, if they specify, like if they say plus or minus the square root of 25, then we would list it as plus or minus 5. Okay. And if it's negative square root of 25, then obviously we're looking for our negative root, so we would put negative 5. Okay. So the key takeaway there is while we're working on these, unless it specifies your symbol on the outside, we're always just going to put the positive root. Okay. So you don't have to worry about putting plus or minus, unless it says specifically in the problem if it leads off of the plus or minus sign. Okay, so the actual work itself. How can we simplify the fifth root of 243, a to the 20th, b to the 25th, which sounds a lot worse than it is. So how we can think of this is we can split it up. So the fifth root of 243 times the fifth root of a to the 20 times the fifth root of b to the 25th. Okay, and the hardest part of this one is actually the 243 here, because you got to think, what number times itself could get me to 243? Now it's odd, so it can't be 2. So what if we try 3? What if I say 3? 3 times 3 is 9. If I keep going, 9 times 3 is 27. Let's go the other way here. 27 times 3 is 81. And let's do one more. 81 times 3, believe it or not, is exactly 243. So since we have 5 3's here, we can rewrite this as 3 to the 5th. Okay? And then if we put it back into our radical, so then we have the fifth root of 3 to the 5th, and whatever our, what was I gonna say? Or if our index matches the exponent on the inside, then we know those are going to cancel out. So the fifth root of 3 to the 5th is simply just 3. Okay. The other way you can think of this is whatever our index is, for every time we can have that many of a digit or a variable, we can pull it outside of our radicals. Like since we had 5 3's, we know our final answer is we're going to have 1 3 on the outside of our radical. Okay? We do the same thing for a. I don't want to actually have to write out 20 different a's though. So we can think of this as division. How many times does 5 go into 20? And hopefully you would say, well, that's 4 times. So I can simplify this to just 4, no, not 4a, but a to the 4th power. So for every 5 a's, right, I can pull 1 outside of my radical. And since I have 20, that's 4 groups of 5, so I can pull out 4, or a to the 4th power. Okay? Then we do the same thing for b. So we say 25 divided by 5 is 5, so we can actually pull b to the 5th power. And all of this works out evenly. This all gets multiplied together. There's no root left over, so our final answer is just 3, a to the 4th, a to the 5th. And that's all we've done is we just simplified our roots, okay? And this one was nice because at the end of the day, if the root went away, it's not usually going to be that simple. So let's look at our second example here to prove why that's the case. So this one, it also throws in a negative at us and another negative. If you have an odd index and we have negative on the inside, we can rewrite this as -1 times 16 times x to the 4th y squared, right? And we can take the cube root of -1. That's just -1 itself. So if we pull the negative out, then we have a negative times a negative. So we know our final answer is actually going to be positive something, right? So that takes care of our negative. I don't even have to worry about that. So anytime you have an odd index and a negative number on the inside, you can pull the negative outside. You can take the cube root of -1. Okay, then we've got 16x to the 4th y squared. So if I start with 16, and I know, instead of doing this separately, let's do all of this as in one shot here. So 16 is 2 times 2, that's 4, times 2 is 8, times 2 is 16, and then I've got 4 x's. This one's a little bit smaller, so I can actually write it out. And then 2 y's, just fits perfect. Okay? So you're saying, Ellis, that doesn't work because our root is the 3rd root, and I have 4 2's. What happened? I say, oh, that's okay, that's okay. So how we think of this is for every 3 of something, right? We can take the cube root of 2 times 2 times 2. This is 2 to the 3rd power, and you can take the 3rd root of that, and you just get 2. So we know part of our answer is going to be positive 2, right? And then we're going to come back for this leftover 2, don't worry. So then I go to my x's. Do I have at least 3 x's? And you say, yep, there they are. So this would be x to the 3rd power and the cube root of that. So that's also going to simplify to just 1x. So we have 2x on the outside so far. I go to my y's. I don't have 3 y's, so I can't simplify that at all. So I'm just going to leave this alone. Okay? So whatever's left, I've got 1, 2, I've got 1x, and I've got 2 y's. All of that's going to stay in my radical. So I'm just going to list them all out. So I have 2 times x times y squared. And then this becomes my answer. We don't actually have to write the plus sign. It would just be 2x times the cube root of 2xy squared. Okay? So you can split it up like this to look at it. Or again, you can think of it like division. And the only part I would actually write out are the number ones, because that's a lot harder to think about. But like when we deal with the x's, like I see x to the 4th. So 4 divided by 3 is 1. And that gives us our 1 we pulled out. But then we'd have 1 as a remainder, right? 4 divided by 3 is 1 with 1 left over. So that leftover, the remainder, is going to stay under your radical. Okay? And then 2 divided by 3 does not, that's a fraction, right? It doesn't go into it one time. So that's why there's no y on the outside. and we have that remainder of 2, so it stays under the bracket. Okay, so try these out. Hopefully as you work through these, it starts to make a little bit more sense. If you're having trouble, let me know. And then assume for all of these that all of our variables are positive. That way we don't have to worry about absolute value. We'll deal with that tomorrow. Okay, so good luck.